Hi, this is David Lamb. We're having some technical issues with the webinar at the moment. It's up, and hopefully it's going to stay up, but it has been dropping out the last 10 minutes or so. So we're going to try and make it work. I apologize if it crashes, and if it keeps remaining unreliable, then we'll just have to reschedule it. So I'm going to hand over to Bob Stroh, and hopefully you'll find some value in this.
Thank you, David, and hopefully you'll find a lot of value in this. The topic that we wanted to cover this morning was heating with Mitsubishi. This is kind of a reinforcement of points we raised with a PowerPoint presentation we were doing in the fall, and we called that Getting the Heat. So we're adding some topics to that, but a lot of this will be a review. So if you were involved with Getting the Heat, you may see some of the same concepts, but it doesn't hurt to have them reinforced. Before we get to the meat of the topic, what we wanted to do was take a quick look back at the results from last year. So, and that's very easy to do when you have numbers like this you can talk about. By any measure, 2012 was a very successful year for both us at Mitsubishi and with Peirce-Phelps. Peirce-Phelps, as you can see, was up with our M&P product 60%. Mitsubishi, as a company nationally, was up in excess of 30%. We also grew our market share by 10%. So, as I say, this was a very successful year, and we recognize the fact that that's due to the effort of the sales teams involved, and more to the point, to the efforts of the contractors that we've been working with in the field for some years now. We hope that it justifies for you the additional time and effort we're asking you to place in the product line. But no results like this occur without a plan. And we had a plan in 2012 that we think we executed well. So we have a plan for 2013 that we want to introduce to you right now. This is what that's going to look like. We want to take the growth that we saw in 2012 and extend that over 2013. So, the brief summary here is that we want to grow in the range of about 40% again. And one of the ways we hope to do that is to make greater use of the co-op funds that are available to the contractors through Peirce-Phelps. Because of the success from last year, we'll have more co-op funds available. So we hope that more contractors will take advantage of those funds and do some local advertising to piggyback on the advertising that Mitsubishi does on a national level. The other components to this program or for the plan for 2013 is that we want to continue the training, and that would be both technical training for service and install people, as well as expanding applications in those areas that we've seen the greatest growth over the last 3 years in particular. And they are within the multi-evaporator systems, as well as expanding what we feel is the greatest area for growth, the heating applications. And that's the point of this webinar this morning. We have a calendar that we want to roll out for you. It'll outline some of the things that we want to plan for each quarter of 2013. So in the first quarter, we're going to continue the heating focus that we had begun through the fall of last year, and that, again, that's part of what this webinar is about. We want to do some one-on-one planning. Over the last several years, we've had meetings for contractors where we brought groups of contractors in and reviewed the product line in terms of application and also some of the marketing plans. We want to do that more in a one-on-one manner for this year. So what we invite contractors to do is get with their TMs and schedule some planning meetings with us. Hopefully at those meetings we can arrive at a co-op plan for you that makes sense for you and for us. And then again in the first quarter, finding time to have techs trained is always a challenge. So generally speaking, the end of the first quarter is usually the best time to do that, and Mitsubishi and Peirce-Phelps have a full schedule of technical training available for the people that fit that category. Second quarter. Second quarter, Peirce-Phelps is going to be rolling out a preseason rebate. This is going to be similar to the rebate they ran last year. It was very successful, and we hope to see the same kind of success this year with that. So look for that beginning in the second quarter. The second quarter is when we hope to do the preseason co-op spend. So we'll be looking at running ads that will highlight Mitsubishi through the spring season.
The broadcast is now starting. All attendees are in listen-only mode.
What?
Product and application training is something that we want to do in the second quarter as well, and that would be us working with salespeople at different contractors. So we'll want to look at product familiarization and also offer some tips on where to best apply ductless split systems. Moving into the third quarter is when we hope you'll be the busiest. So we have plans in the third quarter to take a look at or fine-tune, if you will, our plans for the fall. We want to offer to the contractor base some specific job support. So if you've got jobs that you have or opportunities that you have to turn into Mitsubishi jobs, we'd be happy to work with you on them. But basically, we want to, excuse me, we want to get out of the way in the third quarter and let you do hopefully what we've worked together to do, and that is to apply ductless split systems in as many times as you can. Moving into the fourth quarter, we're going to again reinstitute a fall rebate program that's going to have more of a heating focus. The co-op spend that we're looking at for the fourth quarter is also going to be focused on heating applications. We now have material available in terms of print media and things like that to help us in that area, but we certainly don't want to limit ourselves to those ads that are currently available. We're always looking for some creative ideas on how best to make use of the co-op. And then heating application support is something that will be available throughout the fourth quarter. Again, looking at specific jobs and hopefully addressing any concerns you may have regarding specific heating applications. So that's what the 2013 year looks like. We welcome your comments on that, especially what we hope to see is in the first quarter, we'd like to see people taking advantage of the opportunity for some one-on-one meetings where we can agree on what the best path would be for all of us. Okay, before we get into specifics on the heating, I mentioned earlier that one of the biggest areas of growth for us has been on the multi-evaporator systems. And I don't think we've ever published anything that shows all of the systems that we have available that fit that category of multi-evaporators. If you take a look at the slide, within our MXZ or our M-Series systems, we now, or by June of this year, will have 6 models available that are capable of handling more than one indoor unit. So as you can see, we've got the 2B20s, 2 indoors, 20,000 BTUs of nominal capacity, the 3B24, and you'll notice that those are asterisked. Those 2 models with certain or specific indoor unit combinations do meet the criteria for Energy Star and for the tax credit. Continuing on that list, we have the 3B30, the 4B36, and the 5B42 we expect to see available in June or July of 2013. This was a product we originally spoke about last year, but it has been delayed somewhat. So we hope to see that, as I say, in June or July. And then finally, the MXZ 8D48. Now, when we talk to most contractors outside of commercial contractors, we've really been a little bit negligent in promoting or talking about the city multi-side of our multi-evaporator systems. And those fall under the category within city multi of what we call S-Series. S-Series are city multi-systems with all the city multi-controls and all the city multi-type air handlers available. But the difference with the S-Series is that they are single-phase units. So if you take a look at the systems that are available within the City Multi S-Series, you'll see that we have the PUMY P36, which is a 3-ton unit, capable of handling up to 6 indoor units. We have the PUMY P48. This is going to be a 4-ton unit that you can put up to 8 indoor units on. And then the PUMY P60, that's a new unit. For those of you who may be familiar with the PUMYs, or as we call them, the PUMIs, you may not have seen the P60 yet. That unit was just introduced in December, and it is available now. And just to restate it, one of the nice features of the city multi-side of the multi-evaporator systems is that you have a much wider range of controls to work with. And it also provides more flexibility in terms of line set layouts. So that's a topic we'd like to address in those one-to-one meetings as well. Now, heating with Mitsubishi, these are some of the topics, or these are some of the things that we know are concerns for people when you're trying to kind of step out of the box and look at heating applications for ductless split systems. In the past, that hadn't always been the case, but we feel now with the product lineup we have and with an eye towards the considerations that we'll address, you certainly can feel comfortable using ductless split systems in heating applications. So what we're going to look at are the capacities, the efficiencies, and that's something you need to get yourself familiar with, because being able to address the efficiencies in a coherent way really does help you become a better salesperson for this concept of heating with ductless splits. We'll look at some comparisons, and what we're talking about there will be comparisons of ductless heat pumps to other fuel types. And we're going to talk about considerations, and we're talking primarily the other considerations that we have are auxiliary heat and to some degree the impact of defrost on the heating performance. So we'll get into more of the auxiliary heat options and what you want to look at there. And finally, even for those people who have followed Mitsubishi and are very fluent with all of the product lines that we offer, we're going to be introducing you to something today that I think will be very helpful for you in evaluating these systems for heating applications, and it's called the Mitsubishi Diamond System Builder. This is a city multi-program. It's a sizing and selection program that we'll show you some snapshots of towards the end of this presentation, and I think you'll find that very helpful. Okay, first let's look at the capacities, or how to accurately assess the capacities and what you can expect to see out of these units, particularly at lower outdoor ambience. The slide we're pulling up now is one that for anyone that's been to Mitsubishi presentations that we've conducted, especially over the last 3 years, have probably seen this slide more times than they can count. But it's still, I think, the best way to explain in a graphic way how a variable speed compressor operates and how it affects the capacities that you can expect to see. So the slide that we're looking at now will show a set temperature. We're indicating at the bottom a compressor on cycle, and what we're looking at here is a set temperature of 75 degrees and a room temperature of 90. So the impact that that has on the system when you have that big a temperature spread is that the compressor, as you can see here, will generate high speeds and accelerated performances. Basically, we're running at a speed rated in hertz of about 122 hertz at a maximum. And again, for those of you who've seen this before, I hope you've committed this to memory already, but for those of you who have not, I'd like you to take a mental picture of this because it will affect what we talk about later on when we look at heating capacities at low ambience. So that hertz, or the speed that you're seeing of the compressor running what is in effect above our rated line, affects the performances and the capacity. Now, once we reach set temperature, as you can see on the red line, basically the compressor throttles back, runs at a much lower speed, delivers straight line temperature and much better humidity control in the space. And what we're looking for is low speed on the compressor and, as I said, straight line temperature. Now, I want you to take a look at the compressor run line there in green, because we're going to reference this when we start talking about efficiencies, especially efficiencies as rated in COP. That run line is the biggest thing that will affect the varying COPs that you'll see on in the heating mode. So how does that line affect the specs? What I want you, for any of you who may have a Mitsubishi M-Series catalog, that would be a catalog with a white cover on it. You can find this slide on page 24 of that catalog. And again, this is a slide that we spend a lot of time with. And what I want to point to right now is the ratings for these systems. And for right now, we're going to focus on the first system listed there, which is the MSZ09. Just lost the cursor. There we go. The MSZ-FE09. The FE09 is also designated as one of the hyperheats. It shows us very well in the heating capacity. So if you have not heard this before, I want to draw your attention to two ratings. One is the rated capacity, which you'll see is listed as 9,000 BTUs. Anywhere you see rated, rated indicates the compressor is running at a fixed speed. So in this case, that model running at a fixed speed of 60 hertz will be delivering in cooling 9,000 BTUs. The bigger, or the rating that you really need to pay more attention to is the one that's listed here as capacity range. And what you'll see there is the capacity range for that FE09 is going to run from 2,800 BTUs at a low speed to, in cooling, a high capacity of 9,000 BTUs. So the capacity range indicates what you saw on the earlier slide, that is the actual compressor run line. Now let's move down, since this is a heating conversation, let's move down to heating at 47 degrees, heating at 17 degrees. Now again, with the compressor running at a fixed speed, which is where we get our rated capacity, that is rated by AHRI, you're going to see that we're delivering 10,900 BTUs. That's if the compressor is running basically at 60 hertz, and delivering a fixed speed only, or just running only at a fixed speed, you're going to see 10,900 BTUs. The more important number to look at here is the capacity range. The capacity range in this case is going to run from a low speed of 3,000 BTUs to a high or at high speed 18,000 BTUs. And you can also see right below that the total watts input. Keep losing my cursor here, so bear with me. The watts input are going to be reflected in a couple of minutes when we move from this slide to look at how the capacity range affects the COP. And when we're talking about heat pumps, COP is not necessarily the best measure to use, but it's one that is accepted, and it's one that we can use for comparison with other systems. So the key things to remember here is the capacity range on that unit runs from a low of 3,000 BTUs running at somewhere between 20 and 30 hertz, and a high of 18,000 BTUs with a compressor speed of about 122 hertz. HSPF in this case is going to be just about 10. Now, let's take a look at what the heating capacity is at 17 degrees. With a compressor running at a fixed speed, you're going to see that the heating capacity is 6,700 BTUs. So at 1,700 degrees, if that compressor is running at 60 hertz, that's what it's delivering. The real world is going to be reflected more in the maximum capacity, which you can see there is 12,500 BTUs.
So how did these systems run in the cold spell we had last week?
That's actually a very good question. I was going to address that more when we talked about heating, when we get to other considerations and heating options. And really, how they ran in that cold spell is something that depended, or was dependent upon how well, frankly, people paid attention to these, to this section of the spec sheets. As most of you may know, if we're dealing with hyperheat units, the biggest qualifier to be considered as a hyperheat unit is the ability to deliver the full rated capacity of the system, even at a temperature as low as 5 degrees. So you can see on this system, at 5 degrees, we're delivering the full rated capacity of 10,900 BTUs. Now, the same thing carries these same qualifications, or if you will, classifications, carry through for the entire one-to-one product line. So you can see right next to the 09, the FE09, the FE12, and you can see that even at 5 degrees, the FE12 is going to be delivering 12,500 BTUs. The FE18 is 21,600. Now, please keep in mind, the FEs, or the hyperheats, are the models that are always going to show us in the best light in the heating mode. The FEs are only available as one-to-one systems, not as multi-evaporator systems. But you can see by going across the spec sheet what every one of the one-to-one systems will be providing you at 17 degrees, which is the AHRI rating point. So that's an AHRI number, not our projection. And then you'll also see what the capacity or the heating output should be running at a maximum hertz at 5 degrees as well. Now we have that information available for the one-to-ones, and then we also have it available, as you can see now, for the multi-evaporator systems. And again, just following down the specs on the left-hand side of the spec sheet here, you'll see the capacity ranges listed. You'll see rated capacity, capacity range. You'll see rated capacity at 17 degrees, capacity range at 17 degrees, and then it continues down to your rated capacity at 47 was the earlier one, and 17 is just below that. But the big thing is, what's this thing going to do for you at 5 degrees? So you can see on a 20,000 BTU multi-evaporator system at 5 degrees, you can expect to see just about 11,000 BTUs of heat delivered out of that system. And if you follow across on the that 5-degree line, you'll see what the worst case scenario should be. So to David's point, or David's question about how did these perform, really it all depended on how well people sized the system, or if you will, oversized the systems in order to address the outputs at low ambient. But the big thing is, this information is available to you on all of these spec sheets. It's also available to you in more detail by going to my link drive. That's something we can explain to you at a later date. We didn't plan on covering that today.
So Bob, did we have many dealers, homeowners complaining about lack of heat delivery from the Mitsubishi system?
What we heard in our office was a total of 3.
Okay. So that's pretty good, I guess.
Yeah, and one of them, there was something goofy about it, in all honesty. There was one application where we were having heating difficulties at around 50, so there was something else affecting that system. Without looking at it, I don't know, and I'm not pretending to be a tech guy, but sometimes if you get outside air influencing pipe temperature thermistors and things like that, it'll extend defrost, and that will affect how the units perform. So in that one application, I would look for it to be that having been influenced by something other than the performance of the system. But again, the big thing I want you to have as a takeaway is you need to address what the capacities are going to be for these. We're not telling you that, except for the hyperheats, we are not suggesting to you that you can take any one of our units and apply them universally without the consideration for what we're going to be doing in these low ambient conditions. And we'll talk about auxiliary heating or backup heating in just a couple minutes. Okay, you saw the compressor run curve, and you can see that it varies from a speed, in some cases from 20 or 30 hertz up to 122 hertz. That is going to affect the COP. And since, as I said earlier, the accepted way of measuring efficiencies of heat pumps is in COP or HSPF, we're going to take a look at how the COP ratings are impacted when you apply that across the capacity range. Now, there are an awful lot of numbers on this slide right now, and I apologize for it, but what you'll see here is we've taken the brackets from the spec sheet that was showing you the rated capacity and the ranges at 47 degrees and at 17 degrees. Now, what I want to look at first is the rated capacity. So again, going back to the point we made earlier, the rated capacity is with the compressor running at roughly 60 hertz. And you can see there that at 47 degrees, with the compressor running at 60 hertz, delivering 10,900 BTUs with a total watts input of 710, that your COP is 4.5. Okay, that's great. But in the real world, it runs across the range. And the range of delivered BTUs is what we show right below that. So we had a minimum capacity of 3,000 BTUs. And you can see there that the watts input at that point is only 150 watts. So we're basically doing providing 3,000 BTUs the same way you would run a 150 watt bulb. So the efficiency there becomes 5.9 on the COP scale. That probably outperforms most geosystems. Now, why is that important? If you remember the compressor run line, the way we want to see the compressors run is to over-rev meet the set temperature very quickly, and then dial back down and run at a low speed. So what we look for in most heating applications, especially in that range of 47 degrees, is that most of the time the compressor is going to be running at a very low speed, so you can count on having COPs in this range. And that's a hard thing to argue with. So let's look at what the worst case scenario is at 47 degrees, where you just come into a room, you turn it on to address a cold space, the compressor over revs, runs at 122 hertz, is now delivering 18,000 BTUs, consuming 2,250 watts, and delivering a COP of 2.3. And that is pretty much the worst case scenario you'll see at that temperature. So let's go down to 17 degrees, and you can see what, again, what the rated capacity is and what the COP is. So we're still, even at the rated capacity, with the compressor running again at 60 hertz, we're delivering 6,700 BTUs at a COP of 3. I still think that's pretty darn good to be maintaining a COP of 3 at 17 degrees. We only publish this information at 47 and 17 because 47 and 17 are the AHRI test points, and these are documented numbers, numbers that are documented by AHRI. So I won't go through every model with us, but you can see by moving over to the right what you can expect the COP to look like for the FE12 and the FE18. Now, just to make that slide look even worse, we'll advance it one. And this is too small for even me to read. I don't know if any of you can see it clearly or not, but I just wanted to let you know that what we have available for you is a chart that shows the COP for every one of the one-to-one heat pumps with the same information that we just reviewed for the FE09. So you can see what you can anticipate in terms of efficiencies for all of the one-to-one systems.
Sure. What we will do is make this presentation available, and we're actually recording it. And if you talk to your TMO branch manager, we can give you access to it on our YouTube station.
Thank you. We also have that same information available for the SEZ models. For those of you who aren't aware of those are the horizontal ducted systems, and they are the 9, 12, 15, and 18. So you can get that information, or the COP information for any of the M-series units. This is the same information, but we've also incorporated the SLZs, which are the 2x2 ceiling recess models. So pretty much anything you want to look at on the M-series side, we can give you the COP across the capacity range, and that I think should be very helpful for people. We also have the same COP information available for all of the outdoor units as well. So again, David will be providing this to you, and you can look that up as you find necessary. Another way to look at COPs is something we hope to get across in this chart. And what we have here is a cost per million BTUs. And you can see a dollar value out there on the left-hand side. And what you're looking at there, as you can see, is electric resistance heat, oil, propane. And then we're showing you what the cost per million BTUs operating at a COP of 2 would look like. We're also comparing that to wood pellets. Now we also show what the cost per million BTUs of a heat pump operating a COP of 3 would look like. And then we've got 3.5, we've got gas, and we've got a COP of 4, wood, and then a COP of 4.5. By the way, the lower you are on this, the better. So this chart, I think, it takes the COP range that we just talked about and kind of puts it into a viewable graph that gives you an idea of what your dollar cost might look like. All right, one of the other things we wanted to provide you with was a comparison of electricity for heat pumps versus other fuels. So what we have is a chart that reflects BTUs out by dollars in, and we're comparing that to different fuel types. The top line, which is the only one that you can see fluctuating there, is going to be the electricity used. Now, I want to make it clear that this is a slide that we sort of commandeered from the commercial side. This is a slide that was actually put together to reflect the performance of city multi outdoor units. But the performance of M-series units is almost a direct comparison to the city multi performance as well. So this is a pretty good comparison. This, by the way, is available as an Excel sheet, so you can change the values that we're looking at there in terms of the cost of oil, the cost of electricity, the cost of natural gas. And you'll see the lines, or the intersecting lines, change as you raise or lower the value of the cost of the fuel that you're looking at. So the important thing on this slide is to take a look at where the crossover point comes. In this case, when we're looking at natural gas, by the way, is always going to be the most competitive fuel to heat pumps. When you take a look at the crossover point, you can see that that's going to be down around the range of 5. And we do, if you're interested in seeing what we use as inputs for this, we can certainly share that with you at any time. But the takeaway from this slide is that you have to get pretty cold in order for natural gas to overtake electricity, at least at this point, in terms of the value of BTUs out by dollars in. Now, keep in mind where the crossover points occur, because one of the other things you always have to address is when I'm looking at doing heating with ductless split systems, how many hours am I going to have to concern myself with either auxiliary heat, backup heat, or oversizing the system? Maybe we have a power problem. As you can see on the lost power. I need a full screen. Okay. Okay. Sorry for that. Hopefully you're stuck with us through that little glitch. As I was saying, the last slide we had showed a crossover point, and the consideration of the crossover point is what's going to affect, or determining where the crossover point is going to determine what fuel is most efficient for you, but it also will help you address the idea of where you may need additional heating. As you can see on this slide, what we're looking at is a ASHRAE bin data that shows the number of heating hours in the Philadelphia area. And as you can see from this, Philadelphia currently only reflects about somewhere between 10 and 20 hours, or in the temperature range of 10 to 20, 224 hours in that range. So what we're saying here is that 76% of total heating hours in our geography are above freezing, and 94% of the total heating hours are above a crossover point that we put at 20 degrees. And frankly, that crossover point is at 20 is higher than what it really is in our geography. We also included the heating hours for Atlantic City. And I'm not sure how this works out, but apparently Atlantic City has more hours below 10 degrees than Philadelphia does. But the important takeaway there is that, again, 77% of the total heating hours are above freezing, and 92% of the total heating hours are above a crossover point of 20 degrees. So this kind of gives you a snapshot of how many hours you really need to be thinking about when you're addressing a greater demand for heating capacity at lower outdoor temperatures. Okay, some of the other considerations that we want to look at here involve auxiliary heating options. If you're one of the best uses for ductless split systems is always going to be in a house where you may have a more expensive heating system. And my apologies to anybody who may be an oil dealer in this case, but supplementing the cost of oil heat with ductless split system heat pumps is a great way to go. But the existing boiler, let's say, is a great backup for our systems at lower outdoor temperatures. So tying into an existing system is one option you have for auxiliary heat. The other one is to incorporate backup heat, and there are a couple of ways you can do that. One is with electric strip heat. For those of you who may have used the horizontal ducted units in the past, electric strip heat is a great option. It will go right into the plenum. There are manufacturers that make electric strip heat packages that fit perfectly with the configuration that we have on our SEZ air handlers. Hot water coils would be another option. You have to keep in mind the idea, especially on ducted, of the static pressure that's available. But one of the things we want to stress with you is the way to control any auxiliary heating system. One of the things that we have on most of our indoor units is a pin connector on the indoor board called CN24. And you can use a relay off CN24 that will automatically engage the auxiliary heat type that you choose to use seamlessly. So there would be no second control needed. It would just be done right from our indoor unit. We also just recently introduced another accessory that we call an MAC 333IF, and that also acts as another way to provide sort of a central point or a hub for controlling other devices. And again, when you're taking a look at this heating applications, if you have questions about any one of these things, talk to your Peirce-Phelps salespeople or involve us at Stroh Sales Associates, and we'll get these questions addressed for you. But I want to go back to David's question. We are not diminishing in any way the concern we have that the full heating capacity be addressed at the time you're laying out or designing these systems. So the ways to address that is to take a look at oversizing the system to provide all the heating that you would need from the ductless split system, or looking at one of these other options. But we need that to be the first thing we address when we're looking at doing a whole house or a commercial installation with ductless split systems. Okay, another topic I want to cover is what we call the Diamond System Builder. This is the latest version of what we call within City Multi Design Tool. Design Tool is a program that allows us to build a system, confirm that that system will operate correctly, and Some of the other outputs that you'll see are very useful when you're looking at applying these to heating systems. The Diamond System Builder is the new name for design tool, and it's been upgraded to include the MXZ outputs in both cooling and heating. The benefits are it allows you, through an initial input view, to set your design conditions. And then the outputs that are viewable to you will show the D rates at each air handler in capacity and how those D rates are affected by both the design condition and the line set lengths. So even if you're running long line set lengths, the D rates will be reflected in the outputs that you'll see at each indoor unit. And then the other major benefit to this is that it will show you anticipated discharge air temperatures. Now, we're going to throw up a couple slides here, which are sample systems that we quickly built. But I want to make this point clear to you. We're talking about discharge air temperatures. These discharge air temperatures are going to be a worst case scenario. So anticipated discharge air temperatures are probably going to be a little bit, well, not a little bit, they may be significantly better than that. But the discharge air temperatures are always going to be at the worst design condition with the fan running on full speed. So here's what these things look like. I hope you can all see this. We were doing our best to try to get this into a format that would be viewable for you. What we're showing you here is an MXZ system. And in this case, what we did was take the 4-ton outdoor unit, the MXZ 8B48. You can see that on the left-hand side. Now, what you're looking at there are line set lengths, and you can change those line set lengths, which will affect the output at the indoor units as well. So coming across that line set length, you're going to see that it's incorporated a T, and hopefully if you've used 8B48s in the past, you know that we need to make use of branch boxes. And in this case, we plugged in 2 branch boxes, and you can see that we've got off of the first branch box 3 indoor units, and then 3 indoor units off of the second branch box. You can label all of these when we're doing the inputs for this. You can label what rooms they're going in, and then as you can see here, you've got, let's look at the first one, for example, the MSZ GE09. You'll see the cooling capacity, and then also below it in red, the heating capacity that's anticipated. And Patrick, what did we use for this? Was that 5 or 10 degrees?
That is 10 degrees.
So these, we were using, but by the way, one of the other things about the system builder is that you can create or sort of commit to memory your own design conditions, or you can pick a city and it will give you the ASHRAE design conditions for that city. So it can be something you do manually or almost automatically. And then further on, you'll see the estimated cooling discharge air temp and then the estimated heating discharge air temperature. Now remember, that's a worst case scenario. So these would be discharge air temperatures at 10 degrees with the fan running on high. If you dial back the fan speed a little bit, you're going to, air is going to move slower across the coil, and your discharge air temperature is going to be higher than that. And in most areas, you run a design condition less than 2% of the time, so please keep that in mind. But I think that, again, with the view towards heating with ductless split systems, this is a way you can build a system and view or have viewable to you what the heating outputs should be in each area that you're putting an indoor unit in. We're going to take a look now at what the City Multi S-Series system would look like, making use of the Diamond System Builder. So what we did here was use, again, it's a 4-ton unit. It was what we call a PUMY P48. These do pipe differently than the MXZs, depending upon what your application looks like. Sometimes the piping for a PUMI is easier to manage than even the MXZs. And that's something that, again, we're happy to help you with in terms of making sure we're applying the right product to the job. So in this case, we're showing a 4-ton outdoor unit coming across a line set. As you can see there, we're showing it as 3/8, 5/8. It's 50 feet long. And then we run into a T. From the T, we go out to a 2-ton air handler, which is going to handle a master bedroom suite. And then off the other side of the T, we're going to come to a second T, which is going to deal with a wall mount unit, in this case for a hallway, and then maybe another ducted unit, which will handle a group of bedrooms at the other end of the hallway, let's say. So this would be a typical maybe second floor application. And as I mentioned earlier, when we're working with the city multi-system, you've got 11 different styles of indoor units available to you. So there's almost no need that we can't meet with the city multi-air handlers. Those also include vertical air handlers, by the way, from 12,000 to 54,000 BTUs. So I hope you'll find that you agree that this is useful, especially in addressing concerns that you may have for heating applications. Finally, I want to direct your attention to the federal tax credit. As you may know, as part of the fiscal cliff negotiations, tax credits were extended, and we do have models that will meet that. Those models are listed right here. If you need this information available in a different format, we can certainly get that to you. The thing that's helpful, we think, in this slide is that the AHRI numbers are shown right there on this slide. So just to wrap this up, we continue to believe that the greatest potential for growth is with the wider application of the multi-evaporator systems. And from an application perspective, we believe it really is in the heating area. We think that's an untapped market, and one of the best ways you can sell this to your customers is that the cooling is free when you're going in to provide true zoning on a heating application. And if they didn't have cooling in that space before, they do now. And then finally, one of the things that we want to focus more on this year is using the Mitsubishi Honeywell controller, the MHK1. That is our radio frequency wireless controller. And the thing that we tend to overlook sometimes is that that is able to be incorporated into the into the Honeywell gateway, so that you can have remote access to controlling the space in your house.
We're just going to check the questions.
By the way, the slide you're looking at, if you haven't seen it, is the Mitsubishi training room at Peirce-Phelps.
Okay. Lots of questions. Okay, sorry about the webinar disconnecting. We had a couple of technical problems and also getting the audio up.
Okay.
So the first question was, what's GOP?
GOP. That's not GOP. GOP is the grand old party.
Yeah, I'm going to give my view on that.
We'd rather you keep that to yourself. We don't need English politics intruding in our webinar here.
Morgan of Philadelphia.
COP is a way of valuing, or a way of reflecting efficiencies in heat pumps. And the simplest way to explain COP is that COP, as you can see, is expressed in a ratio or in a value. And let's say that we have a COP rating of a 4.5, as we talked about earlier. The What that means is that for every dollar it costs you to operate that system, you're getting $4.5 out in heat. You can also express it as for every kW, for every kilowatt that you use to operate the system, you're going to be delivering 3,413 BTUs. So again, if Dave, I'm going to rely on you for the math there, but if we're using 1 kW and we've got a COP of 4.5, what does that translate to in BTUs?
A lot.
Thank you. I'm getting a blank look here. Okay.
I couldn't remember COP. Assume the presentation will be available to review in an email. Yes, we will make this available by your PMs, and also we've recorded it, like I said before, so you can actually listen to Bob's silky words as well as the presentation.
I assume you recorded it when we actually had sound.
Yes.
Good.
Is there a fail-safe minimum temp that it will come on looking to do some shore houses that are vacation homes?
Yeah. What you can do, the good thing about, this wasn't always the case, but when we introduced the latest generation of Mitsubishi systems, all of the controllers can be set back in heating to 50 degrees. And that's a great application. Vacation homes, whether they be at the Jersey Shore or in the Pocono Mountains, people want to be able to set them at 50 and forget about it. So yeah, they can dial back to 50. The other thing that I would recommend for vacation homes is seriously taking a look at the MHK1 controller with the gateway. There's so much capability and functionality to that. I have a house at the Jersey Shore as well, and the ability to change temperatures from the road is a great asset.
And one of the other things with the MHK1 and Honeywell is you can set it up so it will route emails to you, the dealer, as well as the homeowner. So you can start to offer enhanced services around looking after the vacation homes. Yeah, question. That was the last question.
Okay. We are sorry for the technical glitches.
I'm sorry, it was my fault. My battery was low, and we had a couple of technical problems at the beginning.
Thank you.
So thank you very much, everyone, and have a great day.